So one thing we should also look at here is we've been given this condition that it's got to be within that range. So if we think about the cosine graph, okay, here's my cosine graph. That's the Math 12 style, right? If we continue it on, do something like this. So right here, these are the pi over 2 and negative pi over 2. So you'll notice that everybody in here is positive. So we can actually drop the brackets for absolute value. We don't need those in there. So unfortunately, it's just the cost, not the absolute value of the cost. So don't go running out, racking up your credit cards. Okay, so now we have to figure out, we know what our integrating function is. We have p and we have q. So we're going to put it in that form, 1 over the integrating factor. And q in this case is just a 1, I believe, yeah. And the integrating factor, which is cos dt. So let's see here. That gives us 1 over cosine of t times cosine t dt. So what's the cosine of t's integral? Yeah, I know we're almost at spring break, but that's an easy one. You should be able to do it. Yeah, it's sine. So it's going to be 1 over cosine of t, and that integral is going to be sine t plus a constant. Yeah, it doesn't sound as cool, but so sine t over cos t plus c over cos. So I can guarantee you that your textbook's answer, your textbook loves doing algebra, so your textbook would probably have this. Squeeze one more step out of you and rewrite it as tangent and secant. Okay? Say that again, Mark. Why is sine t not negative? Did I forget a negative sign?
Oh, right.
It's okay, yeah, I know. It's okay. Just tell your brain to hang on. We're almost there. I know, we're almost there. Okay. So, moving on then. So this one, I'm going to give you a couple minutes to separate it and see what you can do to it. But notice here that it's not set up. The differentials have been pulled apart. So your job is to not only put it in standard form, but to reassemble it also. Okay, so to pull this into standard form, one possibility, there's many that you could have done, but one possibility is to move the dy to the other side. And then, oops, I forgot an x in there. And then divide everybody by dx. So I would get y minus 1 sine x equals dy by dx. And now that I've got my rate of change reassembled, then I can expand here. See what I end up with. Y sine x minus sine x equals dy by dx. And now at least I can see this can be separated into the standard form. So negative sine x equals dy by dx minus y sine x. And now I can see my pieces here. So this would be my standard form for number 1. That means that p of x is equal to negative sine x, and so is q of x. So here's my q of x here. Oh, don't go to sleep. Wait. There we go. Okay. Negative sine x. So I can come up with my integrating factor. And so the value is going to be for negative sine x. So that gives me e to the cos x for my integrating factor. Now, that means I can separate this as 1 over e to the cos x times the integral for q of x, which is negative sine, times e to the cos x dx. And this one's tricky to sort of see at first glance, but you think about it this way. That's my function. That's my derivative. So I know the pattern is present. So we could do a substitution on this, but if you think about it here, this piece has the derivative of the entire thing. E to the cos x has a derivative of e to the cos x times the negative sign. The exponential times the derivative of this function. So that means e to the cos x, it's going to be this piece here, e to the cos x plus a constant. Okay. And if I collect up my like terms, I'm going to have 1 plus e to the cos x.